Here we can see the lab that we are using for shooting all the modules of this course. So this is a single board computer lab which is based on the Raspberry Pi, which is connected through HDMI to this monitor, and it has two USB ports which are connected to this to the keyboard and mouse. The total cost of this is around 13,000, and if you have a smaller monitor then you can go for as low as 10,000 rupees. So the advantage of this kind of lab is you can do almost every single course in electrical engineering in a hands-on fashion using this kind of infrastructure. Okay? So this is something that we recommend for labs in colleges, engineering colleges, or even in high schools. Anybody who wants to learn Python or Arduino or this particular set. Okay? So in this module, we will be seeing how to install the Arduino IDE and how to connect the Arduino via USB to the computer. And the installation of the Arduino IDE is going to be on a Raspberry Pi or a Linux system. So that will be shown. And then we'll show you how to run a simple program where the built-in LED in the Arduino can be blinked using the Arduino IDE, and the computer is connected to the Arduino, and when you run the program, the LED on the Arduino will be blinking. Okay. So this is the first experiment which we will perform and which will be shown to you as part of this module. We hope that this will be helpful to you in getting to know the Arduino environment, the software as well as the hardware connections that are required for you to get your Arduino up and running. Okay.
Start with the installation of Arduino IDE. We'll deal with installation of Arduino IDE on a Linux Ubuntu operating system. First, go to a browser and type arduino.cc. This will open a web page. Then you need to go to the download section under this software heading. There you need to select the version of download for Linux systems, and then on the coming page select just download. Save this file. You can see the progress here. Just click this button and then wait till this thing is done. Now we need to open a terminal here. Then migrate to the downloads directory by typing this command. Now we type ls to see what all folders are available in this downloads directory. There is this tar file. We need to untar it using this GNU decompressor by writing this command. It will take some time, and then you need to type ls again to see whether it has done its work or not. As you can see, there is this Arduino 1.8.7 folder. Now you need to migrate into that folder by typing this command. type ls again to see the contents of this folder. Now in order to install Arduino IDE, you need to run this script file by typing the following command. Followed by the user on which you want to install this Arduino IDE. So for this case, as you can see here, the user is NRC. I'm going to type NRC. It will ask for a password. Give in the password and press enter. It will ask you to restart your system. Just restart your system using reboot and press enter. It will reboot your system. Since now you have rebooted your system, we have on screen a new terminal window. Now you need to type in cd downloads in order to go to the downloads directory. Here, by typing ls, you will see that there is this Arduino folder. You need to move into this folder now. Next, you type ls and just see the content of this folder. Now using this sudo / and Arduino, you can open your Arduino IDE. This is the Arduino IDE. Here you can see this function void setup is actually used to put in the initialization of the pins that are being used in your program, and this void loop is available to keep your program running throughout or repetitively in a loop for infinite times. From tools, you can select which board you are using this option, and from the port section you can select the port on which your Arduino is connected. Generally it is connected to dev TTY ACM0 port. This option is actually used to display all the serial communications that are happening through Arduino. You can save your file by clicking File and then going to Save As and typing in the file name. You can choose a directory. Let's say we have this directory in Documents. Make a new directory with the name Arduino and just save this sketch. In Arduino IDE, whatever code you write is called a sketch. This button is actually used to start the compilation of this code. If this compilation completes successfully, it will display this output. And if you have to upload it to a board, then you need to press this upload button. Since I have not connected any Arduino board, it's not able to find the Arduino board on any of the available ports. So for now, we'll just pause it here. These are all the components that will be used in this video tutorial and the series of video tutorials that will follow. Starting from the top, here we have this resistor of 1 kilo ohm. Then we have this decoder IC, which is used to decode combinations and convert it to drive this 7 segment display. Then we have this D flip-flop IC, which will use as delay or feedback element in the system that we design. Then we have this 7-segment display here. It has 10 pins, out of which 2 of the pins are same. The 2 pins are located on opposite ends here. This and this pin are same. The rest of the 8 pins are used to glow the 8 LEDs which are here. 1, 2, 3, 4, 5, 6, 7, 8. 8 LEDs here. We have this breadboard which is used to design prototype small electronic projects. These pins are shorted column wise and these pins are shorted row wise. These are jumper cables. Male-to-male jumper cables that will be used to connect the breadboard and the Arduino. This is the Arduino board that we'll be using in this tutorial. Here we have 13 digital pins. As you can see, they are marked from D0 to D13. Opposite side here we have analog pins which are 6 in number and they are numbered from A0 to A5. Then we have here 2 ground pins and 2 power supply pins marked as 3.3 and 5 volts. This port is actually USB type B and is used to connect Arduino to the computer through which we'll program this Arduino. This is an external supply port which will be used to connect this Arduino board with an external battery. Here we have this crystal oscillator of 16 MHz value. At the center of this board we have this Atmega 328P microcontroller which will be programmed to control all these pins here and here. Now we'll move on to doing a simple program on this Arduino. In this video, we'll show how to connect the USB wire to the Arduino board and the system. We'll connect this terminal of the USB wire to the Arduino and the flat terminal of the USB wire to the system's USB port, like here. The USB port on the system can be on the front side of the CPU or it can be at the back here, and we connect the wire in this manner. Mentioned earlier, this is the Arduino IDE, and here we can see the setup function which is used to initialize all the pins that we'll be using in our code. This loop function is used to run a part of the program repetitively. Let's just start with glowing the LED, the inbuilt LED on pin 13. Firstly, we'll write pin mode 13, output. Here we have defined the 13th pin as an output port pin. Next, we need to write digital write 13 high. Now, in order to blink it, we need to provide some delay. We provide delay by providing a parameter to this delay function. Here we have chosen 1000 as the parameter to this delay function. We can increase or decrease the value of this parameter. Now we need to turn this LED off by doing this here. Again, we need to provide this delay with appropriate parameter value. Now we just need to burn this code, upload this code to the Arduino board by first clicking on the verify button. Here you can see it shows done compiling. So the code compiled with 0 errors. Now as you can see here, the port is not mentioned to which this Arduino Uno is connected. So to specify that, we need to go to Tools and select the ports from this here. Now it shows on Arduino Genuino Uno on dev tty acm0. Now we can upload our code to the Arduino board using this button. As you can see, the Arduino pins can be seen blinking in the video. Apart from this, there are many pre-specified libraries which can be selected from the examples here, like this blink program, which can be chosen from here.